I'm going to talk about some work that I did before getting into Google that is still ongoing, that I'm still doing now that I'm inside Google, and some work that is being done that I am doing in the company, and just also a little bit about work that's been done by my colleague. So just because I believe it just gives a better, bigger idea of what we want to do. So I think this is going to be also slightly different because, well, it's an industrial talk with a bit of research. I guess it's industrial talk given by researchers, whatever that looks like. But yeah, so I'll get started. So the first project I want to talk about is a project that we were doing in South Africa. This is a project that I got into just out of curiosity, just because I lived there, just because it's home. One of those things of just wanting to understand and see if you can actually apply the techniques that you have in your lab or an office to understand your actual lived world. South Africa is very well known for inequality, I think. That's one of the things we are known for. We're also really known for it being a very beautiful country, just to balance things out there. What is very interesting about South African inequality is that for the longest time, of course, it was part of the constitution. It was an institutionalized thing. And because of that, you see things that you don't always see. One of the things being a very dire disparity between neighborhoods that are just across the street from one another. This is because you had to have a wealthy neighborhood, and then you had to have a place where the labor lives, the labor for the wealthy neighborhood. So this is an inheritance from that. The thing that was interesting for me, and now we are working with a couple of other researchers. This is not just me. And actually, it's been led by a student at Wits University in Johannesburg. This is really, she has taken over actually since I moved to Google. So quite a bit of this work will be her work. Now I don't know where I was going with that thought before I had to give credit where credit was due. Oh, yes. So what was interesting was to understand what has happened since 1994. So all of that was disbanded in 1994, and it would be very interesting to see what has happened in terms of what we call the spatial apartheid since 1994. We wanted to know if anything had changed, if neighborhoods had merged, if neighborhoods had changed, if low-income neighborhoods had become middle-income neighborhoods, whatever it was, because the whole country was changing anyway, and it was interesting to see if spatially we were also changing. So what did we do? The first thing we did was to try and characterize a neighborhood. I'll talk a little bit about the data sets that we had. But basically, we had data sets that pointed to each house that is there. And so you could actually capture, just by segmentation, an area and figure out the shape of that area and, of course, the density of that area. And through that, in a combination of some census data, we started to label our data into what we call townships. And townships are like middle-income Black neighborhoods. They have a definitive form. And then suburbs, these are currently just mixed. Everybody lives there, whomever has enough money to live there. They are usually very lush. So tree detection algorithms would actually pick that up very easily. And then farms, vacant land. And then in South Africa, we also have a lot of informal settlements that just pop up. This was important actually for us to be able to track, because constitutionally, every South African has the right to access to water and electricity and sanitation. So every time a new area pops up, the municipality needs to know so that it figures out a way to best provide these services. And these things pop up all the time. So we look at our data set. So like I said, We had a data set of all of these buildings. This actually came exactly because of this law that that expects every house to have to be connected. And so ESCOM is actually the national energy company, and the CSIR is the national lab where I used to work when I was doing this research. And so these two, we had this data set that marked every house in the country, and this is exactly why we could get this density. Then from there, we also had polygons that were provided by Statistics South Africa. And they gave us the shape files of the neighborhoods and what neighborhood was in which bracket. And so we combined these two data sets and actually many other data sets to label all the neighborhoods that are on the map and then use that as our training data. Because what we wanted to do, remember, eventually is to say, are there any similarities in terms of shape and spatial arrangement as time goes? Like what is similar to what is changing and what is not changing? So first of all, we had to do this characterization, and this is how we did it. So I don't have is it a video? Oh, look at that. I thought I was on the PDF version. I was somewhat not too upset by it. But anyway, so, I mean, this is actually a time lapse of one of these townships, which are formal areas, very well planned, but not very wealthy. They're like lower middle income in South Africa. So we wanted to be able to do something like this, and we wanted to do this for the entire country. And we had a data set for the entire country, except for that labels of what neighborhood looks like what, we only had that for like 2011. This is actually one of the reasons why I've really been feeling myself drawn more and more into this work, is because a lot of these kinds of results can be used as proxies for census, because census are expensive. So we had census the last time in 2011, and so that's why we had these labeled data. So that was our ground truthing, actually came from the 2011 data set. And so, but then we wanted to move forward, and we have data up until like the 2018. We have like the occupation data up to the 2018. So that's that work. We have some preliminary results, which interestingly, I am not sharing. I know. I don't know why I thought maybe I wouldn't share, but I think when I was invited to here, more importantly, I wanted to tell you about the kinds of problems that have been interesting us, even more than the solutions themselves. So I'm going to move to another problem. These things are written up somewhere. I can share with you the links and the papers to the results and the ongoing work and the website actually to visualize, to see the South African project if you want to do that. So I'm going to move on to the next one, which actually evolved out of this. So then I moved to Google, and when I got to Google, I got to meet another colleague who was kind of doing this sort of work. He was doing it in Uganda. I'm trying to find the city. This is bad. I literally hear of Kampala. Thank you, Constant. Thank you. So he was faculty at Makerere University in Kampala, and he was working with the UN to try and understand the problem of from Sudan, all the migration running from the refugee problem that was coming from Sudan, and a lot of refugees would come in and settle in Uganda. So this once again would be like there was no one there, and suddenly pop, there's like a small town. And obviously for the UN, they would want to know where these people are in order to be able once again to offer services. And so, but this actually turned out to be a pretty good Google project for Google, and of course for us. Usually it starts with us, but it's always good when it aligns with the company, because actually these kinds of entities would not necessarily be included on Google Maps. And so we actually had a thing to enrich the map itself, and then of course a lot of other researchers then use this kind of research. Thank you. This data down. So this whole project started as this, but now it has evolved into understanding buildings. I'm still very much interested in understanding the cities in Africa, but my colleague John Quinn, he is overall running this project of just understanding what a house looks like in Africa in order to be able to map out where people are and make that a little bit more visible. Additionally, for us, this is one of those projects where we are building a huge representational model. So you build this model and you train it over this, and it knows what the shape of a house looks like for where we are in the shape of a neighborhood. And then we release this model out to all of the other researchers to then fine tune for their specific neighborhoods that they want to learn. So we're doing this at continental scale. Once again, something that we can only do because we have Google resources, so yay for that. Finally, one of the projects that we just got started and we're moving on and moving slowly is one actually I'm doing with actually Constantine and Joao at the Turing Institute. And I met them when I was in London, and they told me about this beautiful data set that they had. And the data set that they had was very high quality, marked data set on where people reside in different neighborhoods. I specifically wanted to look at the ones in Lagos, Nigeria. And what we want to do now is, so you imagine, so this is a complementary project to the one that John, for example, is running. So let's say we get to a point where we map up the whole continent, and now we can see all the buildings. But that's a very rough estimate of population if you want to replace census. We have a problem that we do not have, in a lot of African cities, you don't have very strong zoning laws, so you cannot separate this out and say, this is industrial, this is this. So you find people living in mixed communities. And so we wanted to know, is there a way we can actually detect, just from a slice, from a satellite image, that one slice, what is the likelihood that it is a high residency image, that image is high residency. So that's ongoing work. It's a tough problem. We kind of also like it that it's a tough problem because it's a problem that feeds back into just fundamental research in machine learning, because it poses a problem of how do you learn over noisy data? How do you learn over small data sets? And overall, the whole problem of generalization, this is something that on the research side is something, we get this opportunity to actually explore. But the results, one of the things is we have things that are definitive signals, like the one I've highlighted in red, that's almost always residential, which means if you've got a high density of square roofs, apparently that's a very strong signal. Other things tend to be a little bit more mixed. Okay, I probably have a minute now. Okay, so some of the things that came up from here, and so I actually, one of the ways that I thought we could supplement this residency data from Lagos was to actually then go in and look at street view data, right? Yay, Google. Because we have that, and we can actually be able to see which buildings are actually commercial from just the detection, just the looking at the signs and whatever characteristics are there. Of course, this also posed an opportunity for us because we do not currently have machine learning algorithms that are very good at detecting the kinds of businesses for us. And so that's an opportunity to build that. But basically, from both of these projects, one of the things that keeps popping out is building ground truth. What is ground truth for the research that you are doing? For the work that with the Turing Institute, it was very good because you literally had people there and walking. For us in our work in South Africa, we are having this thing where the best we can do is just say that this is a predictive result because we do not have ground truth necessarily. Also, the whole thing of characterizing all, deciding this is middle income, this is middle high, and all the ways that we characterize neighborhoods is so noisy. And so the whole thing of deciding what we start off as labels and what is ground truth and what isn't can be tricky. In Africa, and especially in West Africa, more than 50% of industry is informal, which might have things for tax. If we go with Street View and we highlight these businesses, I don't really know if we are being helpful or harmful. And so this has been a question that has come up about documenting people who are not used to being documented, making them visual, making them accessible, without necessarily a lot of the time them knowing that when that Street View car drove down, it was also doing these things. So this has been some practical concerns that have come out from this work. I think it always comes out whenever we're working with personal data. And I just leave it out there for, once again, for us all to decide how we want to move forward. There's benefits, but there's all these other matters. And that's it. Thank you.